Hello everyone, this is Ali Nasser. I'm going to explain the importance of 3D printing for high school technology education. Actually, I will use the paper research called Developing Pre-Engineering Curriculum for 3D Printing Skills for High School Technology Education during my webinar. Let's start by my outline or my agenda. First, I will show the aim of this study and then give you introduction about basics information for 3D printing. Then I will show methodology in this paper research and curriculum development and implementation. Also experiment design and procedures during this paper, and then show result discussion and calculation of our research today. The aim of this study basically is to observe the significance of using 3D printing in pre-engineering curriculum. This study developing an integrated STM CO2 register design course using 3D printing technology. By the way, STEM is an abbreviation for science, technology, engineer, and math education. After developing a pre-engineering curriculum, we conduct a teaching experiment to assess student difference in creative, race, forecast accuracy, and learning performance. And then we will compare the performance of students by manual design and using 3D printing. 182 participate in this study. The result will show significance of 3D printing compared to manual design. Then the student in 3D printing group were able to forecast the outcomes of race significant more accurately than those in group who made their by hand work. No significant difference in learning performance was found in two groups, manual and using 3D printing. Based on these experimental results, the development of curriculum and the teaching recommendation were revised. This research is an important on offering an effective approach to design and implementation of digital manufacturing and pre-engineering curricula in future. Let me give you an introduction about 3D printing. What is 3D printing? 3D printing is a process making a three-dimensional solid object from digital model, which we called 3D printing. Also, it may known as additive manufacturing. The basic concept of 3D printing is using additive technology, where a three-dimensional object is created by layer down successive layer of material. Actually, in Taiwan, engineering and technology education is offered mainly at university, and only rarely in high school. By contrast, high school in the United States have long offered integrated STM course that focus on incorporating interdisciplinary integrated and learning into real-world setting. About the working principle of 3D printing, first we start by model. Actually, 3D model is created in CAD software and then slices them into digital cross section for the machine to printing it. To perform a print, the machine reads an STL file and lays down successive layer of liquid or powder, or other material to make the model from series of cross sections, and then the 3D printing object is completed according to design as shown in this video. These are some products by 3D printing. 3D printing material may be plastic or metal, and maybe also used food materials, something like flour, chocolate, to create some foods like pizza or cake. Application of 3D printing are very important for education, and actually 3D printing called revolutionizing the classroom. We can create a cross section of heart to allow the biology student to study it. Also, chemistry student can print complex molecular shape, and mechanical students or engineering students can print and modify a car, which will be our case in this webinar. And so on. There is many applications we can print model to discuss or to show some points for our students. Actually, 3D printing called revolutionizing the classroom. Indeed, or 3D printing that has the potential to revolutionizing the way we make almost everything. As President Obama said in 2013, 3D printing can make almost everything. Now let me give you an introduction about my research. Actually, in Taiwan, engineering and technology education is offered mainly at university and only rarely in high school. By contrast, high schools in the United States have long offered integrated STEM courses that focus on incorporating interdisciplinary integration and learning into a real-world setting. In recent years, Taiwan Ministry of Education has encouraged university to launch department focusing on new application technology. And this study has developed a pre-engineering curriculum for high school students, combining integrated science, technology, engineering, and mathematics teaching with novel technology application. This curriculum is intended to serve as a model in service teachers to use when developing their own curricula. High school will also organize engineering design activity and teach in a way that integrated interdisciplinary knowledge. This will foster students' high levels of creativity ability, such as design, innovation, and critical thinking. To develop integrated STEM teaching and curricula, STEM knowledge should firstly be explored separately. Hand-on activities can be organized to integrated the knowledge and engineering design procedures. In the past, math and science education focused on imparting abstract theories rather than practical application. Integrated STEM education can help students from association between theory and reality. In terms of new technology, the price of 3D printing are gradually declining due to patent expiration. 3D printing have been listed as a priority item for subsidization in high schools. The proposed curriculum adopts 3D printing technology and 3D technology as a tool to assist students in self-exploration and self-learning, ultimately fostering technology professional who meet the national development standard. The methodology of this paper developed a course to teach the design of CO2 register using 3D printing, coupled with free 3D digital modeling software. This course serves as a project-oriented hand-on curriculum for students to experience interdisciplinary engineering design within a specific technology setting. The study in two parts. Firstly, we developed the course which involves integrated STM knowledge, execution of engineering design procedures, 3D digital modeling, and using 3D printer to create hand-on CO2 register. In second part, we compare the performance of two hand-on CO2 register course, especially handmade and 3D printing, to determine the difference between students' product creativity, prediction accuracy, and learning efficiency. Curriculum development and implementation divided in 8 weeks. The teaching steps for the handmade and 3D printing group were for week 1 show videos about CO2 register races were shown to students simulate their interest and activity. The goal of the hand-on activities were disclosed and handouts were provided. The handouts were used to review the students' acquisitions of knowledge in other subjects, such as the concept of Newton's 3 law of motions and pneumatic and definition of additive manufacturing and engineering surveying. For week number 2 and 3, modular material were given to help students again. Primarily understanding of the register structure. Materials consist of laser cut cores equipped with 80 gram CO2 cartridge for propulsion. Regulation state the core must be over 120 grams in weight. Therefore, students were required to test different materials and design different car bodies to control the weight as shown in these figures. For week number 4, the 5 classes were divided into groups, namely 3D printing group and handmade group as shown in column. During the introduction to subsequent 4 weeks of courses, both groups were showing actually examples of car bodies and were informed of the dimension, limitation, and rule. The handmade group would constructing the register manually using polyurethane blocks. Polyurethane blocks were used instead of balsa block because they are more affordable here in market. Polyurethane blocks are also commonly used for model constructions in many universities. They are readily available and easy to model. Week number 5, students in the 3D printing group were trained in modeling 3D object and illustrating 3-view drawing. Students in the handmade group practiced illustrating 3-view drawing using a pen and block paper. Both groups were instructed to collect that data and illustrate their design concept on handout. For week number 6, students used the collected CO2 register data and the knowledge acquired in the STM course to complete their CO2 register design. Students in the 3D printing group used 1-2-3D design to build their digital mold. Students in handmade group used a variety of machinery, included a drill band saw, grinder, and wire saw to model CO2 register from polyurethane blocks. Now we talk about experimental design and procedures. Aquasci experiment design was developed. 180 students were selected to be in the 3D printing group, and 2 classes with 74 students were selected to be in handmade group. We started teachers instructing students about 3D printing. Add here 3 view drawing on polyurethane blocks, and then students in 3D printing group collaborating to assembly the parts of the register. Now test the race of forecast and the discussion about their design. Then start a straight line of race and finishing their works. The result actually we can receive it by using CBSS to score creativity of the student's car. The mean scores of 7 variables in 3 dimensions are shown here in this table. CBSS is a abbreviation of Creative Product Semantic Scale. The mean score for novelty, sophisticated structure, consistency, and attractiveness in the 3D printing group were significantly higher than those in handmade group. The accuracy of 3D printing group gain 67% was significantly higher than the handmade group, which gain only 30% in accuracy, as we shown here in this table. Now we show discussion and conclusions. The mean score of received CBSS for form, structure, consistency, and attractiveness attained by 3D printing group were significantly higher than those in handmade group, as we talked before. In summary, the students in the 3D printing group were able to make highly precise model compared to handmade group. The mean scores of received CBSS were similar for both group. For the material variable with respect to novelty, as well the variables of durability and usability in functionality dimension. In terms of material, only a few students considering using different material to reinforce the car structure. The course allowed students to maximize their creativity and create attractive models that met engineering standards. The forecast result showed that students in the 3D printing group outperformed those in handmade group in terms of mastering and flexible utilize STM knowledge. And that's all during this webinar. If you have any questions, please comment below this video. I hope this video is helpful for you. My regards, Ali Nasr.